Yes, welcome again in today's project. And in today's project you're going to do the project on distance sensor. We're going to create the distance sensor using Proteus and the Arduino, and you're going to do everything in here from the beginning to the end. We are going to connect all of the components that we need to know using Proteus, and also after that you're going to write the code using the Arduino IDE software. All of those things are going to be done here, and afterwards at the end we are going to test our project by simulating or by running the simulation, and you're going to see everything here so that you can just be able to create your own distance meter using Proteus and Arduino. And afterwards you can also be able to build this project using the actual tools, using the actual Arduino and all of the actual tools. So let us begin by first putting all our components that are needed in this project into our Proteus software. To add any of the components into the screen, you have to press P. Just press P on your keyboard, and this short screen is going to appear. You can just write the component you want. So if I want to add the Arduino component, I can just write here Arduino UNO. I'm going to search for the Arduino UNO. It is this one here. Click it and add. The other component I need, I'm going to be having the ultrasonic sensor. The pronunciation maybe is a problem. Yes, it's here. I'm going to also be having the LCD display. That's going to be showing me the state of the project, maybe what is the distance until now. All of those things are going to be shown in the LCD display. I think you have this library in your Proteus already. Then also I'm going to add the LEDs. I'm going to be using the LEDs for only one purpose. I'm going to set it using my code, of course, that when the distance is less than 300, the LED light emitting diode should be on, and when the distance is between 300 and 700, the blue light emitting diode should be on, and also when the distance is greater than 700, the green light emitting diode should be on. So I'm going to add the 3 light emitting diodes with 3 different colors. Let us begin with this. Also the green one, also the blue one, okay. Let us also add something to add. I think we should add I don't know. Yes, we should add the potentiometer. This potentiometer is going to help us when we want to add or to reduce the distance manually. We are going to use the potentiometer that will be directly connected to the ultrasonic sensor. The ultrasonic sensor has the test pin. For that test pin you're going to connect the potentiometer. So in our Proteus you can just search POT, then directly you're going to see that one there. Okay, now let us add the components and connect every other component to the other component. I'm going to show you clearly everything on how you can connect each component to the other. The Arduino. This one here. Adding the light emitting diodes. Let us also add the ultrasonic sensor. Add also the potentiometer. Yes, those are the components I'll be having in this project. Okay, now connecting every component, I'm going to show you clearly how you can connect all the components to the other. Let us first connect the potentiometer to the ultrasonic sensor. Just try to zoom a little bit. Let us connect this to the test pin. Okay, now let us connect this LCD display to the Arduino. You can just follow the way I'm connecting these pins to the Arduino. This is the LCD display, and it's going to be displaying the state of the project and showing the distance we are measuring. The distance is going to be appearing on the screen right there. Okay, let us also connect this light emitting diodes. The red one is going to be connected, the blue one, I connected the blue one to the pin 6 digital pin of the Arduino, then this to pin 7, and the other one to pin 8. Then I'm going to connect also the ultrasonic sensor to the Arduino. The ultrasonic sensor has two pins to be connected to the Arduino, and that is a trig pin and the echo pin. All these pins help in measuring the distance. Okay, the trig pin, I'm going to just connect it to pin A not the analog pin of the Arduino. Then the echo pin, I'm going to just connect it to pin A1. Then we have this power pin and the ground. We can just get the ground and the power pin from this terminal, from this part here, terminals mode. Getting the power, I'm going to put it somewhere here. I'm going to connect it to the potentiometer and also the ground. We need the ground here. We need the ground also somewhere here. We need also the ground somewhere here, and also somewhere here. First of all, connecting this to the ground. Okay, let us do this. Okay, connecting also this one here to the ground. and connecting this one here also to the ground. And also connecting this 3 light emitting diodes to the ground. Something also for this ultrasonic sensor, we have to connect also the power. Okay, I think everything is now clear and very good for the Proteus part. I just showed you on how to connect all the components in Proteus. Now the remaining part is writing the code using the Arduino IDE software. Just come somewhere here down. Then you're going to begin writing the code for that project. First of all, we're going to include all the libraries that have been used for the project. The only library included in this project that is going to be included is the liquid crystal. That is for the LCD display. Okay, after that, let us also define the pins that have been used for this project. In this liquid crystal, the LCD, we connected the pins from pin 0 to pin 5. So let us just write them here. Okay, let us then define the various other pins that have been used for various components. Okay, for example, the LED, we're going to define the pin later. Also define the pin used for the green LED. Define the pin used for the blue LED, and also define the pin used for the trig pin of the ultrasonic sensor. We're going to also define the pin used for the echo pin of the ultrasonic sensor. Then you're also going to define the other two parameters, that is the duration and the distance. So as to be able to calculate the distance using the ultrasonic sensor, we have to first of all determine the duration. I'm going to show you everything you have to do to get the duration and also to get the distance. First of all, defining the duration, just write long duration. Then the distance is going to be in form of a double, meaning the decimal places. You can write double or float distance. Okay, That's all. Let us now define the pins here. Red is connected to pin 7, blue to pin 6. So red is to pin 7, blue to pin 6, and the green to pin 8. The trig pin is connected to pin A0. Yes, I think so. A0. Then the echo pin to pin A1. That's it. And then after, something else we're going to do now is that we're going to light. We're going to define the pin mode, whether the pin modes are for input or for the output. Looking here for the LED is the output. You have to define all the pins here. Also for the green, it's also the output. For the blue, also the output. Also the trig, this was the output. The trig pin is the output, but for the echo pin, the echo pin is the input. Okay, those are the 5 pins you have to define, whether they are the inputs or the outputs. Okay, the other part now is the part for the LCD. The LCD, first of all, you're going to light this command LCD begin at 16:2. That's the thing you light for the every project when you're going to use the LCD for displaying. The other part is the LCD set cursor. Now you're going to set cursor at a certain coordinates in your LCD. At coordinate 0, 0. What are we going to light here? Let us just light distance meter. Also on the second line, the LCD has 2 lines. This first line we load distance meter. On the second line, now first let us set the cursor to go to the second line. On the second line, that is at coordinate 0, let us say 4, no, let us say 1. We are going to print the word project. Now this is going to display for how long? Let us light here delay. The delay is going to be 1000 milliseconds. Then after those milliseconds, we're going to clear the LCD this way. Okay, now we just finished the void setup loop. Just finish the setup loop. We're going to go to the void loop. First of all, you have to write this command so as to be able to measure the distance. This command is going to be written because when measuring the distance using the ultrasonic sensor, there are certain waves that have to be sent to the object and then returned. That's the way the ultrasonic sensor measures the distance using the trig and the echo pin. So just write this command when measuring the distance using ultrasonic sensor. First of all, digital light, trick, we're going to put it as I, then no, it should be low, then delay, microseconds, 2 of course, then digital light, streak, high, then delay, micro, then microseconds, then digital, write that command. And then after finding the duration that we already defined it there above outside the void loop and the setup loop, the duration, the formula to get the duration is equal to, just write this command, pass in echo I, this one. Then to get the distance from the duration is equal to duration times 0.034 divided by 2. That's a command to get the distance. So we already have the distance. Now what remains now is to assign. As I told you, we have 3 light emitting diodes, red, blue and green. Is it? So we're going to define or to assign that when the distance, if I'm going to use the if statement. I think if you've just learned about programming, you know these simple things. At the distance, if the distance is less than 300, what should we do? When the distance is less than 300, first of all, we have to clear everything that was on the LCD. Then we have to print the following: LCD set cursor at 0,0, LCD at print. We're going to print the distance. First of all, what's the distance? Distance I'm going to print the distance. That's all. Then also we are going to set now the 3 LEDs. When the distance is less than 300, I think the LED should be I and the others should be low, meaning that they should be off. I means on, being on, but low being off. Then all of this is going to take at least, let us delay for 1000 milliseconds. That's all. Then let us copy this and put for the other two. Okay, this was the if statement, and this will be the if else. I mean the else if statement. If the distance is greater than 300 and also the distance is less than 700, what should be done? The red should be low, the blue should be high, and also, yeah, just this way. Let us also add the last one. This should be the else statement. It should be low, and this should be high, this way, and all of this is going to be delaying for at least 500 milliseconds. That's enough. So as you can see, this is all of the code for this project from the beginning to the end. Now let us just run the project and see. No, because we have to export the X file, because so as to be able to run this project, we have to export the X file, and this X file is going to be imported into the Arduino. So as to be able to export the text file, we have to just come here at the top, go to the part of sketch, export combined binary. Because you have to first save the file, I'm going to come here at my desktop. I will go on which folder. Maybe here, project 2. I'm going to save it as distance. Okay, let us see if there are any mistakes. It's going to tell us, and I'm going to rectify the mistake right now before allowing us to put the code into the Arduino. So as you can just see, it is looking for any of the mistakes that you may have mistaken in writing the code. It takes just a few seconds, very few seconds. Almost done. Yes, it's done. Then we come to the Proteus software, double click on the Arduino. You just come here, the place written as program files, click there, then you're going to select, go to the place you just saved that Arduino IDE file. I saved it in project 2 folder in my desktop. It's here as distance. Then you get this first X file, double click it. So we just already uploaded the X file, click OK. Then after, we have to also upload the X file for ultrasonic sensor, and you are to be having this in your library. After downloading the sensor from any of the of the websites, you will be given the sensor itself, and also you'll be given the library for the X file. So I already have it here in my desktop, I mean in my PC, and I'm going to search for it. And for most of the cases, the procedures and the places it will be located are the same. So you can just follow the procedures I'm going to use so as to be able to get it. Just double click on the sensor. The same, come here and double click, go to this PC, then local disk, then go to the place written as program files, lab center electronics. You will see Proteus 8 professional. Go to the place written as data, find the library, and then we are searching for the ultrasonic sensor. Where is the ultrasonic? Yeah, it's here. So we just already uploaded the library, the X file. Click OK. Then you can just try to run the project and see. As you can see, the distance now is 500. Yeah, no, something I mistaken. I think I had to add the space between distance and the number, but I think you can see the number here. So if I try to add the distance here using the potentiometer, it will change here, and it will change here, and also yes, it is now 800, and the LED that is on is LED. When I just take it down, now it is 100 and green is on. So that's all for the distance meter project using Arduino and the ultrasonic sensor, also using the Arduino IDE to write the code. That was all for today. Please don't forget to subscribe, like in this channel to get more of the content on various projects in engineering and in many other fields. Thank you.